Right. Hello everyone, welcome to our lesson on geometry of straight lines and triangles. This is a summary of what we've been doing all along. Okay, so it's a consolidation lesson on the following topics. We've done geometry of intersecting lines, geometry of parallel lines, and geometry of triangles. Okay, I have a few questions that I want us to do. So what you can do when you see the question, you can try to do it on your own before you check the solutions that I'm going to give you. Okay, let's start. In the given diagram, angle Q1 is 130 degrees minus 3x. This is the angle. And then angle Q2, this is angle Q1. Angle Q2 is 2x. This is the angle here. And angle Q3 is the x. And angle Q4 is 50 degrees. Show that PQR is a straight line. So how do we do this? So we know that if PQR is a straight line, then the angles, the adjacent angles must add up to 180 degrees. Okay, let's see if these four angles add up to 180 degrees. So we're going to add them, and then this is angle Q1, this is angle Q2, angle Q3, and angle Q4. Right now, negative 3x plus 2x, that is negative x, then negative x plus x, that's 0. So we remain with 130 plus 50 degrees, which is actually 180 degrees. So we can conclude and say the line PQR is a straight line. PQR is a straight line because the adjacent angles are supplementary. Okay, right, you can mark your work there. And then let's move on to the next one. In the diagram, AB is parallel to CF. Check if you can see those two lines. You see AB and CF there. And then angle B is 40 degrees. This is the angle, which is 40 degrees. Angle BCD, 260 degrees. No, the reflex one. This one, reflex angle. BCD is 260 degrees. And then angle CDE, this one is 60 degrees. Right, prove that CF is parallel to DE. So we're not given that CF is parallel to DE, we have to prove that. So how do we prove that? So we have to check the following. If you want to prove that parallel lines are parallel, is either the alternate angles are equal, or corresponding angles are equal, or co-interior angles are supplementary. So we need to find angle C2. And then if we add angle C2 and to angle D and get 180, it will mean that CF is parallel to DE. Right, so let's start by finding X here. We're given that AB is parallel to CF. So it means angle C1 and angle B are co-interior angles. They must add up to 180 degrees. You see that? And then we substitute our B there, meaning that angle C1 is equal to 140 degrees. If you transpose, and then say 180 degrees minus 40 degrees, you get 140 degrees. So this is 140 degrees. Okay. Right, so now we can get angle C2. We say 260 degrees minus 140 degrees. We'll get C2. So C2 is 120 degrees. See that? Subtract it there, and then we got that. So this is 120 degrees. This angle here. Right, and then let's add angle C2 and angle D. What do we get? Angle C2 and angle D, these two, they give us 180 degrees. So therefore, line CF and line DE are parallel because the co-interior angles are supplementary. Okay, so these two lines are parallel because the co-interior angles are supplementary. Okay, right. Now let's go to the next question. In the diagram, RB is parallel to SD. Check if you can see that. SCT is equal to 36 degrees. Where is it? This angle here. Then BDC is 85 degrees, angle D1 there. You can see that. And then WAX, WAX, where is it? This angle here is 121 degrees. Determine the value of x. So how can we do this? We find that we may find the value of x using different methods. Okay, we may use different methods. Okay, so I'm going to show you two methods here that we can use. Right, let's look at the first one that we can use. We have angle C1, which is 36 degrees, and then angle B1 also and angle C1 are corresponding angles. If you check, line RB is parallel to line CD. So we get angle B1 there. And then the whole angle RBD, the whole angle RBD plus angle D1 must give us 180 degrees because these are co-interior angles. And then from there we'll find our X. Okay, right, that's the first alternative method. So let's try to do that. So we're saying here angle B1 is equal to angle C1. These are corresponding angles. RB is parallel to CD. So this angle is equal to this angle. Okay, because they are corresponding angles. So this is also 36 degrees. Right? And then angle D1 plus angle RBD plus this angle D1 plus this angle, right, is equal to 180 degrees because they are co-interior angles. Angle RBD plus angle D1. D1 is this one here. Okay, they are co-interior angles. They add up to 180 degrees. But angle RBD is 36 plus x, isn't it? So where this RBD, we're going to write 36 plus x. We're going to substitute them. Then we have this, and then now we can solve for x, isn't it? Right, 85 plus 36, that should be 121. And then we transpose 180 minus degrees minus 121 degrees, we get that x is equal to 59 degrees. So this angle is 59 degrees. Okay. So the other method that you can use to find the value of x, and if you check here, what do we have? C1 and C2. Okay, these two angles, these are vertically opposite angles, so they are equal. So it means this angle is 36 degrees. You see that? And then if you check with triangle CDB or BCD, triangle BCD. So this angle and this angle and this angle must add up to 180 degrees. Okay, and then so we add them. So we say angle D1 plus angle C2 plus angle B2 must give us 180 degrees angle sum in triangle. We substitute what we have, and then we can find x. This is 121 degrees, and then we transpose, becomes 180 degrees minus 121 degrees, which is 59 degrees. So this angle is 59 degrees. Okay, right. If you check, we can't use this so A2 and B3 as corresponding angles, or A2, okay, or A1 and B4 as alternate angles, because we haven't proved that QU is parallel to PV. We're not given, and we haven't proven that. So that is the next question actually. So we need to prove that PV is parallel to QU. Please try to do this before I show you. Right, prove that PV is parallel to QU. Okay, let's do this together. Right, now we can find angle Y there. Right, angle Y plus angle A2. These are adjacent angles on a straight line. If you check, this is a straight line, this is a vertex, and then this is a common side. So these are adjacent angles on a straight line. So it meaning that A2 is 121, so angle Y is equal to 59 degrees. So this angle is 59 degrees there. And then if you check, this angle and this angle are equal and they are corresponding angles. So if the corresponding angles are equal, then the two lines PV and QU are what? Are parallel, because our line XT there is the transversal. Okay. Okay, maybe we could have used this found B4 here. You see that B4 and X here are vertically opposite angles, so it's 59. Again, you can say alternate angles are equal. You see that? But that was enough to find that the corresponding angles are equal, so we can conclude and say PV is parallel to QU because corresponding angles are equal. Okay, so that's what we're supposed to do there. Right, and then now this another one. In the diagram, in the triangle ABC, EF is parallel to BC. Okay, you can see that. And BA is produced to D. Then A1 is equal to 7x minus 20. This is the angle we're talking about. And then E1 is equal to 60 degrees. And then F1 is equal to 3x. See that? Right. Now calculate the value of x, hence classify triangle AEF. And then determine the size of B and E2. Okay, let's try to do that. And then after a few minutes, you can continue and check the solutions. Right, let's do this together. So if you check here, this angle A1 is an exterior angle of a triangle. So angle A1 is equal to the sum of the opposite interior angles. So then the reason we say exterior angle of triangle. And this would mean that 7 minus 20 degrees is equal to 60 degrees plus 3x. So this angle here, if we add these two, we'll get the exterior angle, which is A1. Okay, right, and then we can solve for x here. Okay, we collect the like terms, transpose positive 3x, come this to the left becomes negative 3x, negative 20 comes to the right becomes positive 20. And then 7x minus 3x, that is 4x, and then 60 degrees plus 20 is 80 degrees. Then divide by 4 on both sides of the equation. So it means that x is equal to 20 degrees. Now, when we put 20 here, where there's x, 3 times x, that will give us 60 degrees. You see that? So meaning that this triangle is actually an equilateral triangle because this angle also is going to be 60 degrees. 60, 60, which is 120, 180 minus 60, 180 minus 120, 60 degrees. So this is an equilateral triangle. Okay, right. And then the other question is supposed to find angle B and angle E2. Oh, those ones are very easy. If you check angle B and angle E1, what type of angles are these ones? EF is parallel to BC, check. So these are corresponding angles, isn't it? And then if you check also E1 and E2, they are adjacent angles on a straight line. You see that? So it will be easy to find angle B1, angle B and angle E2. So angle B is equal to 60 degrees because what? Because they are corresponding angles. EF is parallel to BC. And then angle E1 plus angle E2, angle E1 plus angle E2 must give us what? Or these two, E1 and B are equal, so I can use one symbol here. And then angle E1 plus angle E2 is equal to 180 degrees. These are adjacent angles on a straight line. This is a straight line, common vertex, and a common side, or common arm. You see that? And then we know angle E1 is 60 degrees. Then we transpose this, comes this side, becomes 180 degrees minus 60 degrees. E2 is 120 degrees. Done. Okay, let's do the last question. It's been a long one, so let's do the last question. In triangle PQR, TS is parallel to QR. You can see that Determine the value of x. Okay, you can pause the video here and try to do this on your own. Let's do this together. So angle R and angle T1, they are equal. Why? Because they are corresponding angles. TS is parallel to QR. So this angle here is also 3x plus 10 degrees. Okay. And then if you check here with triangle PST. Okay, so if we add the interior angles of triangle PST, we will be able to find our x. Okay, so now angle T1 plus angle S1 plus angle P is equal to 180 degrees, was angle sum in triangle. Let's substitute what we have there. Okay, we substituted there. And then we can collect the like terms. 3x plus 3x, that's 4x. Then 10 plus 30 degrees, that is 40 degrees. 40 plus 60 plus 20, that's 60 degrees. Then we subtract both sides. You see that? And then this transpose, this 60 degrees come this side. And then becomes 4x equal to 120 degrees. And divide by 4 on both sides of the equation. Divide by 4. And then get that x is equal to 30 degrees. Done? Okay? Right. So this is the summary of what? Of the geometry of intersecting lines, the geometry of parallel lines, and geometry of triangles. Thank you very much. We're going to meet in our next lesson.